Newton's second law. Newton's second law answers the question, what happens when a body is under the action of a non-zero force? In this situation, the body can neither be stationary nor in uniform rectilinear motion, as this is the case where the resultant is null. If it cannot be stationary and not at inconstant speed, the body can only have acceleration. But how is this acceleration? What does it depend on? Newton's answer is that acceleration has the same direction as the resulting force. If the force has a constant value, the acceleration will also be constant. But what does the acceleration value depends on? When the same resulting force is applied to different bodies, the acceleration is greater in the body that offers the least opposition to this movement, that is, in the one that has less inertia, and the body that offers the greatest opposition acquires lower acceleration, that is, that has greater inertia. So, for the same force, bodies with greater inertia acquire less acceleration and vice versa, in an exactly proportional way. It is experimentally verified that the value of the inertia of a body is directly related to the mass of the body. Greater mass, greater inertia; less mass, less inertia. The mathematical relationship between these three quantities, force, mass and acceleration, the Newton's second law, then is F equals ma. But why does a force accelerate a quantity of matter exactly proportionally? Why is it that the greater the mass, the lesser is the acceleration exactly proportionally? Why is it that the greater is the force, the greater is the acceleration exactly proportionally? After all, why F equals ma? What is the physical meaning of this constant proportionality? The answer to this question, which seems to be quite difficult, and therefore the Newton's second law is simply accepted as dogma, without explanation, may be quite simple. It is proportionately more difficult to accelerate a locomotive than an automobile due to the inertia of bodies, due to the inertial masses of bodies, that is, their quantities of matter or movement reserves. How can mass be a reserve of movement? Since Einstein we know that every mass has its equivalent in energy, that mass can be converted into energy, and energy can be used to do work, through a force that produces displacement in another material body, causing it to enter into movement. Thus the mass of one body can be used to put another body into motion, or, mass can be converted into motion, and mass is a reserved amount of motion. A force is just a mutual interaction between two bodies. Now if two bodies are two reserved quantities of motion and force is an interaction between two bodies, then force is just a transfer of motion. Force is always a transference of movement, and it always alters the amount of reserved movement or the inertial mass of a body, which is responsible for its local state of motion, or, in other words, cannot be detached from it. Acceleration is just one type of movement. Masses can perfectly well be admitted as being energy or movement reserves, and force is always a transference of movement, which is still movement. The exact proportionality of F equals ma therefore comes from the same nature of the concepts involved. A force when applied to a certain amount of matter accelerates this mass in an exactly proportional way because the concepts acceleration and mass only represent and are nothing more than movements. Both mass and acceleration are just motions. When we realize this, we notice that the second law closing in on itself like an oyster. The perfection of Newton's second law comes from the fact that F equals ma lists three concepts that seem to be different things but which turn out, more deeply, to be identical, equal. From the simplicity of always talking about the same thing comes all the beauty of the cohesion of the Newton's second law. Mass can be seen as just space vibrating inertially. Just as light can be seen as space vibrating inertially in one direction, mass can be seen as space vibrating stationary in relation to the viewer. Why can't a material body under an acceleration from 0 meters per second goes to, say, 1,000,000 meters per second in 1 second, even when we have enough power to do so? The answer is that because it is just a well-defined type of movement, the material body offers resistance to other types of movement and cannot withstand a very drastic or violent change in its state or in itself, not without being destroyed or greatly modified. Movement is a concept that can only exist locally, has local validity, is relative, and depends on certain limits. This fact strips the mass of meaning for the universe, for the whole. We are also just motion, and so we do not exist for the universe, for the whole, not as we, nor as matter, nor as motion. A maxim about the universe would say that the universe is very cruel to the people. Maybe not so much, because despite the indifference, it allows our existence.